In this video, we're going to go over box plots like these ones here, and histograms like this one here. But to start, what is a box plot? Well, it's always got a box or a rectangle in the middle, and then it's got whiskers or tails on each side. Now, a box plot is always going to separate data into 4 equal groups, so even if they don't look like it, 1, 2, 3, 4, all 4 of those have the same amount of data within them. Okay, but we want to find how do you represent or draw a box plot. So let's do it for this data set here. To start, the minimum or smallest value is 15. And like you probably thought, that's going to go on the left side here. So the first one, this one does have a minimum of 15, so that's correct. Same thing for B, that's the correct minimum. But then C, if we go straight down, that has a minimum at 16. So that one's no good. Okay, moving along, the first quartile or Q1, that's the left side of the box. We'll go ahead and label that here. And going straight down, this one is 18. But that is correct. So this one does have the correct Q1 value. Okay, what about B? Same thing. Going straight down, that's got a value of 18. That's what we wanted as well. Then we get to the mean and the median. But we're only going to plot one of these things, so which of them is it going to be? Well, for the first graph, they plot the mean, and that's 21 for this data set. And then the second one, they plot the median going down there. We see that's 22. But we want to split the data into equal groups, and the median is the thing that's going to do it. So this is the correct thing that we want to plot right here. Because the median, it always finds the middle of the data set. So half of the values are below 22, half the values are above 22. But the mean, it does not split it in half, so that's not going to form equal groups here. So that's the key. Don't plot the mean, do plot the median, and then you can find the correct box plot for any data set here. And to finish it off, the Q3 or third quartile, that'll always be on the right side of the box. We'll label that. And 27 is the correct value. And on the far right, just like you were thinking, that's going to be the max or the biggest value. So 33 is the correct one. So as long as you know where these 5 values go, you'll be good to create any box plot here. Okay, let's check out another one. A box plot is also known as a box and whisker plot. Which of these represents the data that's given? But you know what to do. Feel free to pause and try this one on your own. And let's go ahead and do it. So the minimum, the smallest value, should be 7 here. Let's go ahead and label those. The first one, that's got it right. The next one, that's got 8, so that's no good. Get rid of that. And then the last one, that's good as well. Okay, moving on, we've got Q1. We know that that's the left side of the box. The first one has a value of 11, and that is correct. And same thing with the last one. So both of these are correct so far. But we know we're not going to plot the mean. We'll just go ahead and get rid of that immediately. And we need the middle line to be at 15. That'll be the correct median here. So what about the first one? Well, going down there, we see that's 14. So A, that's not the correct graph. We need the median at 15. But the last one, that does plot the correct median there. So here we go. Once again, if you know these 3 values, you can usually find the correct box plot, even if you didn't finish with the remaining values. Okay, but how would you actually interpret the data for a box plot? Let's look. For this one, this box plot represents student scores on an exam. The lowest score was a 55, the highest score was 100, and most students scored somewhere around here between 65 and 90. Okay, so that's all fine so far, but the key is there should be 4 equal groups represented here. So each chunk represents 25%. Therefore, 25% of students scored between 55 and 65, or within this whisker. Then 25% scored between 65 and 75, the median there, and so on all the way down there. Knowing this is going to help us with which of the following statements is true about this box plot. The first one, the mean score on the exam was 75. So let's find the mean of 75. Well, that's right in the middle, but that's not the mean. We know that that's the median instead. So that statement is not true, because the middle line always shows us the median instead. Okay, the next one. 50% of students scored between 65 and 90. Let's find both of those scores here. 65 is here, 90 is here. So does this middle part of the graph represent 50%? Well, it does, because 25 plus 25, the box represents the middle 50% of the data. In other words, 50% of students did score between 65 and 90. So B, the statement is true. But let's double check the other ones just to make sure. 10% of students scored between 90 and 100. Let's highlight that. Now 90 is here, 100 is here. Let's go ahead and show this. But looking up, we see, wait a minute, that's the whole whisker. That's going to represent 25%. So 25% of students scored between 90 and 100, not 10%. So C, that one's incorrect, just like we thought. And then the last one. The inner quartile range is 30. Now, range has a very specific definition. In math, it means the biggest value, which is 100, minus the smallest value, which was 55. So 100 minus 55, the range for the whole data would be 45. But they're asking us about the inner quartile range. Now you might think, well, wait a minute, I've seen this word before, quartile. Where is that? Well, the left side of the box is the first quartile. The right side of the box is the third quartile. Everything in between there is called the inner quartile. Inner means between, so between these two quartiles, that's the data that we're interested in. Okay, finally, to find the inner quartile range, we're still going to do biggest minus the smallest, just for the box itself. Biggest value, 90. Smallest value, 65. And using the calculator, that'll give us 25. So the inner quartile range is not 30, it's actually 25. So again, we knew that one was not right. And this is the key. If you know that each of these is a 25% chunk, then you can solve a lot of different problems by knowing this. And now, if you know what the inner quartile part is, the box in the middle, that can help unlock additional problems there. By the way, one last thing, if you ever see Q2, it's another name for the median, since that's the second quarter of data, 50 cents or 50% up to there. Okay, so now you're a master of box plots. Let's go ahead and look at some histograms. Well, what is a histogram? It basically shows you the distribution or frequency of a data set. Here we have the distribution of flu cases throughout a flu season. The flu season starts in October and it ends in April, and it looks like it reaches a peak, or a majority of the cases happen in late January. Okay, well, let's look at a specific value, like this second rectangle. What does this tell us? Well, it starts on November 11th, and then it goes up to November 25th. So during this 2-week period, we have a height of 2 if we go straight across. This tells us that 2% of the flu cases happened between November 11th and November 25th. Okay, the question is, what percent of cases were reported from December 23rd to February 16th? December 23rd is right here, but notice we don't have February 16th, we have February 17th. That starts the new rectangle here. But the old one ended one day before on February 16th, so we're interested in this timeline right here. Okay, but to find the percent of flu cases that happened, those are on the left side. In other words, we need to add the heights of these 4 rectangles here. We'll go ahead and start with this one. Going straight across, we see 12. So 12% of flu cases happened in between this time period here. Okay, next, between January 6th, a little ominous, and January 19th, what percent of cases happened here? Going straight across again, that's in between, that's got to be 15 this time. This one, going straight across, we see, okay, that's 16. And then the last one, going across once more, we get 14. Finally, we're going to add all 4 of these values to find what percent of cases happened during this timeline here. But the good news is you get to use the calculator that they give you, so let's just do it that way. We've got 12 plus 15 plus 16 plus 14. Go ahead and finish that off here. 16 and 14. And enter. That gives us 57. So final answer, just type in 57 here. 57% of flu cases happened between December 23rd and February 16th. So that's all for this one. Okay, let's look at another type next. This time we want to match the correct histogram with a data table. Which histogram represents the data that's given? They say that a library tracked the number of books borrowed each hour from 10 a.m. to 6 p.m. So at 10 a.m. during this hour, 12 books were borrowed. And then starting at 11 during that hour, 28 books, all the way down. But to match it with the correct data set, it's usually helpful to find where is the biggest value here. Well, we see that that's at 54. Let's highlight that. Now, if the biggest value happened here, this is going to be the tallest part of the graph. It's going to be 1, 2, 3, 4 rectangles in. So let's see. 1, 2, 3, 4. This is the highest part of the graph here. So it definitely could be A. That's looking good. Okay, B. 1, 2, 3, 4. This is not the highest. That happens at the end. So B, this one's no good. Okay, C. 1, 2, 3, 4. This is the biggest again. But let's pause here because you may notice, well, if we go straight across, that actually hits perfectly at 60. So we want it to be the biggest, but we want to make sure that the number actually represents it as well. So A, this is below 60, that could be 54, but this is exactly 60, and that's too big. So unfortunately, C, that's not the right one. Okay, then the last one. 1, 2, 3, 4, that's the highest, and it also looks to be below 60, so this one could be good there. Okay, next, we want to look for a pattern in the data, and it seems like it goes up until we get to 54, or the values all increase. Therefore, we want the graph to go up 1, 2, 3 times till we get to the max. So this one goes up 1, 2, 3, and that is correct. That's good so far. The last one goes up 1, 2, 3, so that one's good as well. Okay, but then we go from the biggest value all the way down to 11. So let's draw this out. We actually go down 1, 2, 3, 4 times in a row. The graph should look like stairs that go down 4 times. But A, it only goes down once and then jumps up and increases. But this is no good because we don't go down once and then up again. We keep going down, so A is not the correct option. But the last one does. We start at the biggest and we go down 1, 2, 3, 4 steps. And that's exactly what the numbers did here. So by looking for a pattern in what the data does, that can definitely help us find which graph is correct here.